Well, good afternoon, everyone, or maybe good morning or evening, depending where you're joining us from. Welcome here to the Launchpad and our live coverage of today's Astra presentation at the Spacetech Day, Astra's first event at their rocket factory. And we are excited to see what updates we will get from them today. Today's speakers will include Kemp, Kelyn, Brannon, Martin Attiq, I'm probably saying that wrong, Benjamin Lyon, and Adam London, who will be speaking today from the Bay Area Rocket Factory at their inaugural Spacetech Day. They'll be sharing information about their products and giving participants and us a preview of what's next for Astra. We're going to be getting started here in just a couple of minutes. We're waiting for them to get underway, but as always, take a moment, let us know in the chat where you're watching from, and if you have questions through today's presentation, you can send those in the chat. Just tag us at the Launchpad. Don't forget to take a moment, engage that like and subscribe button. It really helps us out, and share out the broadcast, as many people didn't know this event was going to happen, and we're glad to be able to bring it to you today to see what the future of Astra will look like. Many people are believing we are going to see some renders, or maybe even the first Astra Rocket 4 models or mock-ups. So we're very excited to see what Kemp and his team present today for the future of Astra. We should get underway here in just a couple of minutes, so stay with us right here on the Launchpad for our live coverage of today's Astra presentation from Spacetech Day.
hard problems attract amazing people. And the chance to get to work with a bunch of really great people on really hard problems is something very special.
4 years ago, Adam London and I quietly founded Astra with a bold mission to improve life on Earth from space.
Our goal is to expand access to space so dramatically that we deliver things to orbit every day. But it always starts with one.
Astra's LV0007 has successfully reached orbit. There is a new orbital rocket.
This is an incredibly hard thing to do. Continuing to do it is incredibly hard, so we're just getting started.
First motion. Vehicle has cleared the tower.
LV0009, it's on its way to space.
There is fairing separation.
Great news to report. The payloads have started to communicate with ground stations. Our customers are calling us and indicating that satellites are alive. They're talking, which means they've been successfully deployed. We're excited to see you back here very soon for our serial number 10 flight.
Good morning, everyone, and welcome to Astra's inaugural Spacetech Day. I'm Kelyn Brannon, and I'm the Chief Financial Officer at Astra. And it was my honor to invite you here today to join me, our leadership, and the rest of our Astra team at our Bay Area rocket factory. We're very excited to share more about our mission, vision, and strategy with you. But here comes a little bit of the boring part. Before we get started, I want to go over some important reminders for you. Today's event will contain forward-looking statements. These forward-looking statements refer to future events, including Astra's future plans, product, and outlook. When used today, the words anticipate, could, enable, estimate, intend, expect, believe, potential, will, should, project, and similar expressions as they relate to Astra are, as such, a forward-looking statement. These forward-looking statements are subject to a number of risks and uncertainties, and as a result, Astra's actual future results and performance, including our ability to achieve many plans, ideas, and goals that we may discuss today, may differ materially from those discussed during this event. We encourage you to review our filings with the SEC, in which we describe the factors that could cause actual results to differ materially from our current expectations. Today, we'll also reference non-GAAP financial measures, which we believe to be useful to investors, as our management team uses these non-GAAP financial measures to plan, monitor, and evaluate our financial performance. These non-GAAP financial measures exclude certain items and should not be considered as a substitute for comparable GAAP financial measures. Astra's methods of computing these non-GAAP financial measures may differ from similar non-GAAP financial measures used by other companies. A description of these items, along with the reconciliation of our non-GAAP financial measures to the most comparable GAAP financial measures, can be found in our earnings release furnished to the SEC on May 5th, 2022. You're going to have an opportunity to see a ton of our technology today. This is an ITAR facility, and we have limited in-person attendance to U.S. persons only for this reason. If you were to take a photograph of an object that is ITAR controlled and published it, this is a potential federal offense. For this reason, we're implementing the following rules about cameras. You can take photos of the presentation and stage from your seat only. As we separate into groups for tours, we will ask you to put your phone in the secure bag that your tour guides will provide, and at no point during the tour may you remove your phone from the bag. If you remove your phone from the bag without permission or take a photograph outside the permitted seating area, you will be asked to leave the building. If you must take calls, we ask that you do so from the front lobby. Your guide will point you there. A little other logistic. Restrooms are back by the inventory cage, so that is back that way against the wall, both men's and women, and we would ask you to use those facilities. We will also take a few questions from the room and online at the end. Please submit those to the QR code or the code on the screen. Now I'd like to invite the Honorable Mayor of Alameda, Marilyn Ezzy Ashcraft, up to the stage. Mayor Ashcraft and the City of Alameda have been incredibly supportive to Astra as we have developed and upgraded this facility, and we are so grateful to the Mayor and the City for their continued support.
Thank you so much, Kelyn, and good morning, everyone. And thank you to Chris Kemp for inviting me here today, and welcome to everyone who's here to watch the inaugural Spacetech Day of Astra. It is great to be here at Astra with you, and as the Mayor of Alameda, I'm delighted to learn that 63 members of Astra's workforce call Alameda home, because Alameda is a great place to live, work, and play. I'm also told that over the last year, Astra has grown its employee base by 285%. That is impressive. Astra is located here in the Enterprise District at Alameda Point, which is our former Naval Air Station from back in the World War II days. Actually, it was built a little before that. And our vision, the city's vision for this area, is to transform old airplane hangars and industrial buildings like this that used to be used to overhaul and repair jet engines, to transform those into a thriving employment center that promotes research and development, high tech, manufacturing, and sales. And I am thinking that Chris Kemp and Astra could do for Alameda what Elon Musk and Tesla did for Fremont, but without any controversies, right, Chris? Right. And so right next door to where we are here is what we call Site A. You're right, we need more creative names, but we've been working hard on developing this area into new homes, residential, also retail, and parks. Those new homes could be homes to more Astra staff, just saying. The City of Alameda is also deeply committed to sustainability and resiliency. So we were proud to open our third ferry terminal. We're an island, after all. We need water transport. But last July, we opened the new Seaplane Lagoon ferry terminal, literally walking distance from here. And ferries from Seaplane Lagoon provide 20-minute service to and from San Francisco. You will not find a pleasanter, more beautiful, stress-free commute. And the ferry terminal is served by AC Transit Line 78, which provides cross-island service to meet every ferry arrival and departure, starting and ending at the Fruitvale BART station in Oakland. And by providing alternatives to automobile transport, we also help reduce traffic congestion and greenhouse gas emissions that contribute to global warming and lead to sea level rise, which is an existential threat, especially to our island community. I understand that Astra supports sustainability by subsidizing public transportation for its employees and providing on-site bicycle storage, and that 27% of Astra's employees bike, take public transit, including the ferry, and carpool to work. Yay you. Good work, and please keep up that good work. Let's get more of you to join the non-automobile transport way to get to work. Astra is also engaging with the Alameda community in a variety of ways, including preparing a STEM project that will support the Alameda Boys and Girls Club, donating to Alameda Education Fund, which supports all of our classrooms across the city, and working with the College of Alameda to establish internships and graduate to hire programs, and leading local cleanup efforts for Earth Day. I'm so pleased to join you for this exciting event, and I'm looking forward to hearing more now from Chris Kemp. But I want to wish Astra every success in all your ventures. Thank you again, everyone, for being here. Thank you.
Thank you, Mayor Ashcraft, for joining us. It is now my deep pleasure to bring up Astra's founder, chairman, and CEO, Chris Kemp.
Thanks, Kelyn. Yeah, it's such an incredible honor to have you all come and visit us today. And for the hundreds of you that were able to tune into our webcast today, we've got an incredible morning set up. For those of you who are here, we're going to be unveiling some of the details of our product roadmap, our strategy. For those of you here, we're going to do some tours. You're going to actually see some of the hardware that we're going to talk about in the presentation today. And we're going to be sharing as much of this as we can on the live webcast as well. So as we get started, I want to underscore why we're all here today. I think that in the last 50 years, I have never seen a more significant opportunity to improve life on Earth than from space. And as we look over the past few months, the impact of space has been clear. When this image was taken on February 15th, Vladimir Putin was talking about how his troops were retreating from Ukraine. This is a picture of the Pripyat River, where on the Russian-Belarus border, a pontoon bridge was built, and 4 hours after Putin said he was retreating, this bridge was imaged from a Planet Labs satellite. This is a startup that didn't exist a few years ago that is showing us that one of the world's most powerful leaders and most powerful nations was lying to us all. And the images that we're seeing from companies like Planet and Maxar are providing an unprecedented level of honesty, truth, and transparency to world affairs that we've never seen before. When the leader of this country needed to communicate with the outside world, to reach us, he didn't use CNN, he didn't use the internet, he used TikTok, connected through a Starlink terminal. And there's been an effort to try to connect the country, not through infrastructure that we take for granted, because that's all been destroyed, but through space, through a constellation of satellites in low Earth orbit that are providing connectivity to the front lines, to our troops, to our allies in this country. This is a private company that didn't exist again with this service just 5 years ago. We're about to see and hear from NASA. We're going to hear about how a satellite that used to be the size of a car has been shrunken down to a 10 by 30 centimeter cube. And we're able to see inside hurricanes with unprecedented temporal resolution to understand their trajectories so that we can get people out of harm's way and we can evacuate people before the hurricane strikes. This kind of capability simply didn't exist a few years ago, and through a collaboration between MIT and NASA, we're able to deploy an entire constellation of satellites in just a few months. So the precedent here is we see these opportunities to use space to improve life on Earth, you have to be able to get to space. And the problem is, with hundreds of new companies building new applications and new small satellites, they have to wait to get to space. They have to wait until a rideshare mission, a large rocket, is going to the place in space where they need to go. And until then, they can't get their satellite into space. And so, if you look at this opportunity, it is truly being gated by access to space. If you have a new application, a new sensor that you're trying to develop, and you have a business that you're trying to fund, a service that you're trying to provide, and you can't get it into space, you're held back. Your revenue streams are held back. Your fundraising is held back. Your ability to make progress is held back. And so as we see this trillion-dollar opportunity unfolding in both public and private companies alike over the next several decades, we see access to space as the key enabler for unlocking the new space economy. And so just in the last year, we've seen almost a dozen companies, I believe, go public, raising billions of dollars of capital to build new applications across global communications, IoT, Earth observation, national security applications. These are real businesses that are generating real revenue, solving real problems here on Earth from space. And this wasn't the case 10 years ago or 20 years ago. We have customers that have collectively raised billions of dollars to build satellites to have a huge impact here on Earth. And so when Adam and I first met, and I can't believe that this picture was taken just over 5 years ago in a garage in San Francisco, we imagined the potential of space. We imagined the idea of dramatically increasing access of space. In fact, we coined the phrase daily space delivery. And literally on day one, and I think Scott Stanford is somewhere in the audience, when we first raised our first money to build this business, the idea was simple. Let's scale the number of launches. And that's a theme that we're going to be talking about throughout today, and you'll be seeing throughout your tours and throughout the conversations we're having throughout the morning. But it is our shared vision of a healthier and more connected planet that truly inspires everyone here in the building. And I think that we might all go to space for other reasons, to settle other planets, to spread humanity into the solar system. But for Adam and I, and for the whole team here at Astra, and for almost all of our customers, the mission is here on Earth. And the opportunity to improve life on Earth through these dimensions of a healthier planet and a more connected planet is truly something that has inspired all of the things that you'll see today, everything that's here in the building. And so the approach that we took was not to design and create PowerPoints and do it all of analysis and then 5 or 10 years later finally maybe build a rocket. It was within 18 months of founding the company in that garage, getting a launch license and launching our first rocket, and then doing it again a few months later, and again and again and again and again. This was not the popular way to approach this problem. You typically not want to iterate with a rocket, but we felt we could learn so much more quickly if we pulled the entire system together, and importantly, also to iterate all the pieces of the rocket, we needed to build a factory that could actually manufacture a lot of the components of the rocket. And so what you'll see today is a factory that's actually manufacturing from raw materials, aluminum tubes, aluminum bricks, aluminum sheets, most of the components of the rocket. At that loading dock, materials come in. At that loading dock, that leaves the building. And throughout the tours today, you'll be able to see how we make most of the components of this rocket, the tanks, the structures, the valves, the engines, electronics, here in this building. And of all the images that are on the screen, I'm most proud of this final one. That's an image that we took from space when we first put our first satellite in Earth orbit. So this iterative process actually allowed this team, the smallest team ever assembled, to put into Earth orbit satellites 4 years faster than any other company in history, and maybe 8 or 10 years faster than many of our peers in this industry. This learning faster mentality of building, iterating, learning is deeply baked into our culture here at Astra. And everything that we approach, our space products, our space services, will benefit from this vertical integration and this commitment to learning and iterating as quickly as possible. So now that we've gotten to space and we've deployed satellites into Earth orbit for our customers, the mission is to scale. The mission is to make more rockets. And so we're scaling our launch services as quickly as possible by taking the company public, by investing capital in the machines that will allow us to remove labor from key components, to continue to drive the cost of the launch vehicle down. And in a few minutes, you're going to hear from my co-founder about how essential this is to winning the market in the small launch vehicle space. So by ramping up our operations, we're also focused on a mobile launch architecture. So not just having a spaceport that is a fixed fortification, but having a mobile launch system that can truly be deployed anywhere we are licensed to operate in the world in just a few days with just a few people. And this will allow us to fly from more places on Earth to more places in space more easily. In fact, we have 3 of these mobile launch systems that we are deploying and able to deploy anywhere within just a few days. And you'll see them here today. We're really excited to, we are operating now out of 2 spaceports, Kodiak, Alaska, and the the one in Florida, right? Been there a lot. Cape Canaveral, of course. Slick 46. We're also excited to introduce a new location in the UK. This is a location that we're working with the regional authorities to get licensed to operate. This is a site that will be able to operate perhaps the first launch, an orbital launch out of Europe. If you think about what scale allows you to do, if you scale up your rocket, you end up with the lowest cost per kilogram, undeniably. The rocket equation is clear. The bigger the rocket gets, the less the fraction of the overall mass of the rocket is the avionics and is all the mechanisms that control things. So the larger the payload capacity that you can have. Makes sense. A container ship, a 777, has a lot of capacity. And it's very inexpensive to operate on a per pound basis. But what we'll assert today is that if you scale up the factory and you drive the cost of the rocket down through economies of scale, economies of scale apply to rockets just like they apply to everything else in the world. The more of them you make, the lower the cost. And the drivers behind this are not how many times you reuse the rocket, but it's about how many times you reuse the factory to make more rockets. So what inspires us at Astra is the aluminum can. What inspires us is taking the complexity of the rocket, simplifying it so that we can remove the parts. The simpler we make it, the more automated we make the system, the lower the cost, the lower the unit cost of the rocket is. Textron makes small aircraft, the Cessna, if you're pilots. Textron makes a few hundred Cessnas per year. They cost a few $100,000 each. And it might not surprise you that, which is LV-11, one of our Tropics launches coming up, weighs about as much as a Cessna. And so if Textron can make a few hundred Cessnas a year for a few $100,000 each, why should this cost millions and millions and millions of dollars? It's actually a tube with a pointy end, and it has far fewer moving parts. The engines don't have pistons, they don't have magnetos, they don't have, the details really matter with rockets. But it doesn't have to cost more if you control the cost of the production of all the parts. And you make a lot of them, because then you can amortize this across a larger number of units that are being produced. So from day one, Astra's mission was to focus on simplification and scale. And through simplification and scale, the economics of launch tip in our favor. And so in the end, you can win in this at both ends of the spectrum. You can either have the largest rocket, and you can reuse it more than anyone else, or you can have the largest factory, and you can make more rockets that launch more frequently and provide more value by saving your customers time. For every large aircraft that takes off from San Francisco Airport, how many small ones take off? For every container ship that pulls up to a port, how many trucks come in and deliver the actual shipping containers? The ratio is typically 1 to 1,000, right? And rockets are no different. Our ability to responsively launch our customers' payloads exactly where they need to go in space on their exact schedules has real economic value. And when you drive the cost of the system down through mass production, we will make a strong argument that there are winners on both sides of this curve. And Astra intends to be a winner on the right side of that curve. So what I'd like to do now is calibrate this with a customer that I'm honored to introduce and talk with here live, NASA. I used to work at NASA, and the opportunity to come partner with Adam and this entire team at Astra to build rockets to launch NASA satellites is probably one of the most incredible things for me personally. And we are so proud and so inspired as a team to be able to launch NASA's first small satellite, Earth Science Constellation. And so with me today, I would like to introduce the Tropics Mission.
NASA should focus on. Number one on the list is to observe the Earth's climate. The Tropics Mission is a mission that Americans really care about because it is directly observing our climate and helping save lives and protect property.
Tropics has a very specific need for their orbital configuration. We need to go to a 30-degree inclined orbit, and no one else really wants to go there. The rideshares are all going to sun-synchronous orbits or mid-inclinations, so it's very well targeted to a smaller vehicle with a very targeted insertion where they can get us exactly where we want to go, and Astra is perfect for that.
NASA selected Astra because of our unique ability to get to 3 different orbital planes in a very short period of time at a low cost. And so being able to launch 3 different times for $8 million is unprecedented.
We're excited about this mission because it's NASA's first constellation built from small satellites. And Astra's platform is really ideal because it allows us to deploy these satellites rapidly and to the precise locations where they're needed in order to make the constellation operational as soon as possible.
And we have the honor of being the final and most important piece at this moment in time of their mission, which is get that hardware in space, exactly where it needs to go. We see that there are increasingly smaller satellites that are smarter, that are doing cool things in orbit, but they need to go to particular destinations at particular times.
The real end game here is improving our ability to forecast tropical cyclones. What we're trying to do is make measurements in the microwave wavelength region, and those have the advantage of being able to penetrate the cloud tops and see the storm thermodynamics underneath the clouds. We're going to get something we've never had before in the history of weather satellites, which is revisit rates of better than 1 hour.
For the team itself, this will be a massive culmination of the last 3 years of work of developing this launch system to be able to do these things that we set out to do from the very beginning.
From Astra's perspective, it's really important because we believe in space at scale. And to do that, you need to have much more frequent launches and access to space. And so this has been an opportunity for us to really understand how can we further compress the turnaround time between launches, both in terms of building the rockets and in conducting the launches.
What this milestone means for us is delivering a really important mission for our customer, but also demonstrating a capability that others can leverage in the future.
And so the opportunity to be a part of something like Tropics, where you get to make a difference and make a really large impact in the lives of people and help humanity as a whole, does mean a lot to me, and it really excites me as well going into this mission, knowing that we can help do something to make the world a better, safer place for people.
All right, so now I am joined by Dr. Will McCarty, the program scientist for NASA from Washington. We're going to be talking a little bit about the upcoming Tropics mission, and he's also going to share a little bit of detail, because he manages the portfolio of small satellite missions at NASA, about his vision for NASA's use of platforms like Astra. So, Dr. Will McCarty, welcome.
Hey, how are you doing? Do you hear me all right?
Yeah, perfectly.
Excellent.
Yeah, thanks for joining us.
Yeah. Go ahead.
Oh, just tell us a little bit more about NASA's Earth Science program and how this mission fits into your portfolio.
Yeah, so to understand what my position is at NASA, I'm a program scientist. I'm a program scientist in the Weather and Atmospheric Dynamics Focus Area, which is one column of the Earth Science Division, which falls under the entire umbrella of the Science Mission Directorate. So basically, to understand what I do, it helps to know my background. My background's actually, I am a meteorologist by training. I come from essentially a weather modeling perspective. And so, you know, it's the idea of what can we use NASA satellites, NASA resources for to basically improve the weather. But of course, the weather then affects everything, because the weather affects the composition. You know, we have not just that you have extra CO2 or extra pollution, but how that blows around, that falls back to weather. And so my portfolio is, it's both big and small. I do the Global Precipitation Measurements mission, which is a large satellite that measures precipitation plus or minus 60 degrees all over the globe. I do the Aqua mission, which is actually just launched 20 years ago last week, which really revolutionized weather forecasting by basically measuring with vertical integrity that never had been seen before in the infrared. But these were big school bus missions. These are large, right? And then what I'm also have been able to adapt to is the small world. And so Tropics is coming up. It's really exciting. It's, shoe boxes that essentially can measure, the vertical profiles of the atmosphere in the tropics. We have the Cygnus mission, which actually measures reflected GNSS signals, so GPS and also other constellations around the world. And you can actually measure wind speed and soil moisture using those signals. And then finally, which really has been how I've been in with industry, is I've basically been with since the inception, the commercial small sat data acquisition program. So that's the idea there is NASA comes in and basically buys commercial data and tries to use it for our scientific objectives. So you mentioned Planet earlier. Planet's one of our customers. We basically buy access to Planet's portfolio. We buy it with a latency because that's how we kind of keep it affordable for science. But there's a lot of this data that's coming out there, Planet, Spire being like two of the big ones that have kind of been around since the beginning, that we want to make sure that their data, if it is useful to us, and we go through an evaluation process with all the new vendors to make sure it is, but if it's useful to us, we want to get it in the hand of our scientists so that our scientists can basically better understand their scientific objectives, whether that be in my focus area or anywhere within the Earth system. So that kind of helps, explain my portfolio. I'm relatively new to the job, 4 months, so things like Tropics. I was excited 4 months ago about Tropics from a user perspective. Now I'm at the headquarters level, but this is a big step forward for us, I think, and it adds a lot of information.
Now, can you talk a little bit more about how this satellite compares to some of these school bus size or some of these large, automobile size satellites in terms of its capabilities, given how it's being deployed?
Yeah, the engineering of it, I'll admit, is over my head. I'm just a lowly scientist. But, the fact that we're building these little 3U CubeSats, shoe boxes, that can literally do what satellites that have been doing for 40 years now. But, they used to be, like you said, the size of, a refrigerator, if not larger. And they would get 4 channels. This one's going to have like 15 channels, which is what our best have now. It's measuring at different frequencies. That's how you shrink things down. But it's going to give us the ability to basically measure the vertical profiles of temperature in and around hurricanes, the vertical profiles of the water vapor in and around the hurricane, and also image the hurricane itself. So we can kind of do that with existing satellites, but with existing satellites, we get a picture when the satellite goes around, and in Leo, they get basically 2 pictures a day. With Tropics, we're going to get this ability of not just seeing them, but seeing them with multiple revisits and quick rapid revisits. So, with adding even just adding a second orbit to one orbit allows us to then see the time evolution. And the time evolution is really the important part that we're missing here. The time evolution, when you feed that to the models, that doesn't just the temperature and moisture that you see directly, but it allows the models to understand how the wind fields are adjusting too, because you have to adjust the wind fields based on how the storm is evolving over these short time periods. And that then results in, basically more accurate predictions. So, and then you can just think of how that scales, right? You could literally launch dozens and dozens of orbits, but the reality of it is you can't do it with one orbit because the Earth's always spinning beneath you. So you have to kind of put up complementary orbits to get that revisit. But that revisit is really what we're missing in the modern observing system.
So the mission's been designed so that the more satellites, the more launches, the higher the revisit rate is, right? So can you talk to me more about what you consider mission success and how the mission was designed and kind of how you chose Astra as a provider, given how early we are in our program?
Right. Yeah. Well, the idea here is this is a fairly new paradigm for NASA that we would, basically be able to build 6 relatively inexpensive satellites through the Earth Venture program. The Earth Venture program is a neat program in that it's basically very experimental, right? The proposals are written by the PI with both the engineering side of how to build the instrument, but also the scientific objectives that they're trying to reach. And so the idea here was, okay, you could build these things and now we could build them and we could put them up into space. But if you think of traditional launch services, we'd be spending many multiples of the instruments themselves to get 2 orbits out of this, this constellation, or +2, So Astra provides this low-cost opportunity, and this low-cost opportunity really opens up an entire slew of different scientific objectives, not just for Tropics, which is kind of the first example, but it really opens up the whole world as we develop these small satellites. But a lot of those scientific objectives can't just ride along to the space station, which is where, let's face it, many CubeSats up until now have gone, because we send things routinely to the space station. You get to pick your orbit now. There's no reason to send a communication satellite, or something that commercial entities would likely put up into space, into some of the orbits we want to use for Earth science. So you're really able to go places that there's no other reason to go, and that's what's really exciting to us. Is instead of having to, this basically allows the small satellites to be the primary payload, and that's kind of unachievable right now in the world we're at.
Yeah, so the mission was designed so that you would have some number of these satellites successfully deployed in order to have minimum success criteria for the overall program. Can you talk more about that?
Yeah, so it's basically our minimum threshold is 2 orbits. We need 2 orbits to be able to see that time evolution, right? It's the first 2 pages of the flip book. We have 3, hopefully we get 3, that'd be awesome, because then you even get that second page in the flip book. But really, 2 is a huge step for us. The only way we get that temporal revisit right now is basically geostationary orbit. In geostationary orbit, you're way up higher, so you have lower signal to noise, and you only see a disk of the Earth. You don't get to see the whole circumference of the Earth. So the idea here is that 2 times 4, or 2 times 2, so 4 satellites. That really gives us our baseline. But I look at these things not just for what we're doing with Tropics, but where we go in the future. And the reality of it is that this is the first step towards a new paradigm, and a paradigm that's already existing. I mean, Planet Labs is flying up there with how many satellites? Inspire has an entire constellation. This is the ability for NASA to build our scientific objective primary payloads to then kind of work in that same space.
It's exciting when the cost of the satellite continues to come down, the cost of the launch comes down. What matters is the constellation and the service it provides, not any one launch or any one satellite. So I know the team will do everything we can to make sure all 3 launches and all your satellites are deployed, but it's good to know that the price point of 3 launches allowed you to enable a mission where even if only 2 were successful, like the last 2 of our 3 launches were successful. So we'd like to do better, but it is nice to know that even NASA is designing constellations so that the overall constellation performance is the end goal, not thinking about every single satellite and every single rocket launch.
Yeah, that's a really important point, is our objectives are really, with this new capability in hand, our scientific objectives are really built on the constellation, not the individual instrument. And so that's something that's very different than what we've done traditionally with these school buses, where one instrument exists on one satellite.
So you've already launched one of these satellites on a SpaceX flight. Can you tell us a bit more about what the satellite has already been able to do for the program?
Yeah, it's actually been, so just as, these are experimental, untried technologies, right? So what they did was basically, there was a 7th Tropics satellite, and it was their engineering bench model. And after completing everything, it was realized, wow, the bench model could basically be thrown up as a secondary payload and go up into space and give us basically some early look data to understand how it's going to function. So, every satellite that goes up into space has its nuances. In Earth science, we think very much at the lowest level, calibration level. Everything has to be completely understood. That's how you get climate. You need climate quality data to get to that point. So the Pathfinder is what we're calling it. That's the first satellite. The Pathfinder is in a sun-synchronous orbit, and what that basically has allowed us to do is refine and test our calibration methodologies on real data versus, what we think we're going to have coming out of the lab. But the other thing that's really cool about that is that we've actually hopefully extended through the beginning of the mission, where then we'll actually overlap the ones going this way with this way, and we'll get better overlap. So you get a lot more simultaneous measurements from the Pathfinder, which we understand pretty well by now, but that also allows us to cross-calibrate the prime constellation with each other, so that one of the great mysteries of these constellations is how well are we going to be able to get them to match each other. One thing you lose by shrinking down generally is calibration stability. That's one of the arguments. But by having the Pathfinder up there, we've already demonstrated end-to-end the observation itself. And now we're going to be able to use that really to make the constellation in better agreement with each other across the board.
Well, Dr. Will McCarty, I appreciate you joining us today. If you were here, you'd see we have LV-10 about to leave the building, LV-11 here next to the stage, and on the production line, LV-12 and other things. So we'll shoot some video of it and send it to you. Thank you for inspiring me, everyone here at Astra. This mission is really important to us, and we're going to do everything we can to deliver for you and your team.
We appreciate it.
Thank you.
Fun stuff. So good.
All right. I'd like to dig a little bit more into this idea of scaling the number of launch vehicles, the economics and the rocket science behind it. And there is no better person to do that than my co-founder, our Chief Technology Officer, Dr. Adam London. So with that, Adam.
Thank you, Chris. Welcome to the Rocket Factory. Thank you all for coming. I'm excited to get up here and spend a few minutes talking about the question that we get asked a lot, which is why small rockets? Fundamentally, there are three reasons that I'll highlight. First, orbital complexity, similar to what Chris and Will were just speaking about, makes small rockets very useful, versatile, and valuable to our customers like NASA and others. Second, the economies of scale make small rockets cost effective. And third, small rockets are frankly easier to make than big rockets, and so it's actually capital efficient to do that as a company that's new and growing. So let's get into it with a bit of astrodynamics. I like to say that there are many addresses in space. On your home, you have your street number, your street, and your zip code. In space, there are actually 6 things that define an orbit, but 3 are most important as well. The altitude, so that's how high above the Earth you're circling. The inclination, which is the plane that your orbit is in, how far is that above the equatorial plane of the Earth? And then the rotation of that plane, which is basically where, as you clock it around the Earth, does your satellite cross the equator. And that's called the local time of the ascending node for a sun-synchronous orbit, or the right ascension of the ascending node for sort of a more generic orbits. And fundamentally, constellations are built up of many planes. So we just heard about the Tropics mission. That's 3 planes, 2 orbits per plane. All of them have the same altitude and inclination, but the 3 orbits are clocked in rotation 120 degrees so that they are evenly distributed around the Earth. And the thing that you need to know from the sort of rocket science set of things is that it's really expensive from a time and energy perspective to change planes in particular, but even any of your space addresses once you're in space. And so that's one of the reasons why Tropics is so much easier to do with 3 launches than trying to do it with 1 bigger launch and waiting for a very long time to get the things to the right locations. As you look at other bigger constellations, there are some that have been proposed with thousands of satellites and hundreds of planes. And this gets very, very complicated. But fundamentally, it's important, if at all possible, to launch directly into the correct orbit, go direct delivery to the right space address. And that is fundamentally what our dedicated launch service is designed to do. So what do our customers need as they're building and deploying these constellations? Initially, they need deployment to all of their orbital addresses. Then, over the life of a mission, they'll need to add spares or move spares or replacement during operations, which go to specific individual addresses. And then at the end of life, they'll want to replenish the constellation. And that means all addresses have to be touched. But if satellites last different amounts of time, you don't want to go to them all in the same order. So you want to be able to very precisely replenish potentially 1 satellite at a time, maximizing the value of that very expensive asset. And perhaps most importantly, our customers want to do this quickly. Because time is money, particularly in space. When you're launching a satellite that costs a lot of money, you need it to generate the revenue to bring that back. And this typically means that a month of a satellite's time is worth 10 to hundreds of thousands of dollars. And that actually can really help benefit the idea of responsive quick launch. So Astra is out to solve all of these problems. Whenever you need to get something in space quickly, we would love to help, and our responsive capability and scale, we believe, will enable that. When you're deploying low-density constellations like Tropics, which is 6 satellites but spread all the way around the Earth, a small system like Astra is often the best and the fastest option to make that happen. In higher density constellations where you can benefit from the bulk deployment of very large rockets, Astra still has a role to play. We think we can complement them by delivering those last few satellites required to finish out each of your orbital planes, or by supplementing the bulk capacity for a small subset of your total thing to accelerate deployment and make the whole constellation operational faster at a really fairly small incremental cost to the average delivery cost. In terms of the on-orbit and during operations phases, we think we shine as well. If a satellite fails or needs to be quickly replaced, we can help do that. And then as satellites near the end of their useful lives, we think that it's quite unlikely a whole plane is going to get to end of life at the same time. And so we aim to enable a more focused replenishment than might otherwise be possible. Economies of scale, we talk about scale a lot, are so core to our strategy, and so I wanted to talk about the concept briefly. What this is, which is one of my favorite charts, is if you buy a rocket or an airplane or a car and you put it on a scale, how much does it weigh, and how many dollars did you pay for each of those dry kilograms? When you step back and think about rockets, airplanes, cars, you think, well, those are totally different. But in fact, they're fairly similar. They're mostly metal, although more and more are being made from carbon fiber. They're run by pretty complicated engines, and they have a growing amount of avionics and software that makes it all work. But you produce them at tremendously different rates. The demand is very different. And that is the thing that fundamentally drives the cost that you can buy a car for tens of dollars per kilogram, but rockets are thousands today. And so ultimately, because these physical devices, they start with the same stuff, like aluminum costs a few dollars a pound, no matter more or less what. So the commodities that make them up is sort of at the bottom or even below this chart. And as you think about each of these charts is how much time and energy, capital go into converting those fairly inexpensive, although recently trending upwards, commodities into a unit of something useful, this amazing device that we then go use. And so our objective, and I think the fundamental reason why this comes down is that you can invest more in the automation, in the manufacturing, in the efficiency of production. And so our objective is to move our small rockets down around to the bottom level of airplanes. As Chris said earlier, if a Cessna can be that much, can't a rocket of similar size? So what does this mean for small launch economics? And why did we choose, and do we continue to choose, to develop a small rocket instead of a very large one? I like numbers and I like charts, so try to avoid too much of a lecture. The sort of traditional view is that small launch is much more expensive on a per satellite basis or a per kilogram basis than big launch. And that's borne out when you look at today's pricing on a price dollars per kilogram basis. But if you think about what is possible if you reduce the cost through scale of small launch, it gets quite a bit better. And if you account for the value, or in the inverse, the cost of losing time of big launch, they start to become much more similar on a per cost basis. And then there's something that many of you in the audience and we care deeply about, which is capital efficiency and the return on capital. The amount of time and money and effort to develop a program that can build a 10 to 20 times larger rocket costs quite a bit more than that of a small rocket. And so when you amortize those costs over a fixed amount of time, the sort of true economic cost of these bigger programs on a per mass launch basis increases, and they start to become even more similar. So in short, we believe that over time, on a per kilogram basis, large rockets will probably continue to be more cost effective. But we think that delta is going to get smaller and be much smaller than what you experience today. Of course, on a per launch basis, which is the thing that drives many of these higher value things of quick access and responsiveness, it's not even close because we're able to produce a smaller thing. And so at a high level, I'd summarize our strategy as we're using scale to obtain dramatically better cost per launch, but at a very reasonable cost per kilogram. And that is what we think fundamentally enables us to deliver for our customers and provide these high-value constellation deployment, maintenance, and replenishment services. Before I hand it back to Chris, there's one other thing I wanted to cover. Way back in my management consulting days, we like to talk about what are going to be the frequently raised objections to this idea. So let's cover one of those. As you might imagine, I get a lot of questions about reusability. Why aren't you reusing your rockets? And so let me say this first. Reusability and reusable rockets are incredibly cool. One of the most amazing and impressive things that I've ever had the privilege to witness was those 2 Falcon Heavy boosters landing in unison in 2018. What an accomplishment. I suspect that I have a better appreciation than many on sort of how challenging and impressive that was, and I remain profoundly in awe of that. But I think it's important to talk a bit about the economics and sort of how we think about this question. Conventional reasoning looks sort of like this. The cost of a launch, of conducting a launch, is pretty much the same, whether it's reusable or not. And if you can reuse a rocket 4 times, that means each launch is a quarter of the cost of the rocket, and 20 times a 20th. And so it's a no-brainer. You should reuse rockets. But my view that things are a little more complicated, particularly when you consider the economies of scale. First, recovery and refurbishment does add additional per-launch operational costs, so those costs are not constant. Second, and perhaps most fundamentally, producing 4 or 20 times fewer rockets, each of which, frankly, is more complicated, likely larger, likely needs higher margins, often is sort of somewhat lower performing for these reasons, means that the per-launch production cost is actually quite a bit more than this quarter or 1/20th kind of factor that one would just apply. And third, reusing rockets is hard. Reusing a rocket, or building and designing a rocket that can be reused 20 or 50 times is really hard. And so you have to think about the program and capital costs that need to be amortized over all of those launches. And so we actually believe that as you introduce reusability, the costs go up initially, and then eventually will come down. And our modeling and our analysis suggests that that payoff is somewhere in the range of 20 to 50 reuses. It's highly dependent on the specifics, but pretty sure it's not 2 to 4. And so fundamentally, when you think about this, like, do I want to invest more capital to potentially get a benefit after the end of things? I'm very, very happy to focus on making rockets simple. That's hard enough. And so we remain intensely focused on scaling dedicated launch. I will acknowledge it's certainly possible that we're wrong about this. There are lots of people who believe we are, but our model so far and our understanding leads us to move in this direction. As we scale and as we learn more, we'll keep evaluating the economics. And if or when we believe it makes sense to reuse, we'll absolutely consider investing. But for now, simple rockets made at scale. That's what we're about. That's what I'm very excited to do here. And I think that's what ultimately will enable us to really meet and help our customers and provide great value. It's important to acknowledge one thing about that, though. To achieve that scale and to solve these future launch challenges for all of our Constellation customers, we need a scalable launch system that is capable of launching almost every single satellite produced, even if it's only 1 or 2 at a time. And that means that our launch system needs to get a little bit bigger. And so I'd like to turn it over to Chris to talk about the next step we're taking on that front. Thank you all.
Awesome. So I'm about to share with you some really exciting work. The team has been iterating since day one. Launch System 1.0, Rocket 1.0, Rocket 2.0, Rocket 3.0, 3.1, 3.2. That's version 3.3 of a system that over a 5-year period of time has gotten better and better and better. And so as we talk about Astra strategy, we talk about our launch services, because you can't improve life on Earth from space if you can't get to space. We talk about the space services themselves and our progress towards building that platform in space. And we talk about the core technologies and the products that we need to power that platform. And so what I'm going to dive into is each of those 3 areas in a bit more depth. But first, we're going to start with Launch System 2.0. We called this one 1.0 because it's the first one that worked. It's the first one that delivered our customers' satellites into Earth orbit. But this is a system that's now been operated and developed over the last couple of years, about 18, 24 months. And so over this year, the team has been working to build the next version of the rocket, 4.0, a new version of the launcher, a new version of the software that powers the entire system, and a new version of the factory to make it all. And so what we're going to dive into today, and we're going to hear from Benjamin, a really deep dive into everything happening here in the building. And what I'm going to talk about is the design goals for Launch System 2.0. We focus primarily on 3 areas: cadence, capacity, and cost. And so if you think about this, this is the North Star for every product team working on every single component of this system. And if you think about the overall launch system, we're talking about rocket engines, we're talking about stages, we're talking about the overall launcher, we're talking about all the ground support equipment. All this stuff has to work together. So having clarity and focus and purpose is critical to bringing it all together time and time again. But before we get into cadence, I just want to underscore how infrequent launches actually are. In Q1, it might surprise you that Astra followed SpaceX, Russia, and China as tied for the 2nd most frequent orbital launch on Earth. We tied with ULA, that also had 2 launches last quarter. And in a way, we're not really proud of this. This just shows you how few launches occur on Earth every quarter. And by doing 3 more launches for NASA, if Russia's not launching anymore, how quickly we move up that list and how infrequent launches truly are available to all these customers that are building all these small satellites, these innovative applications that need to be, as Adam explained, launched to a particular address in space as fast as possible. And so this new launch system is designed for weekly launch. And what we mean by that is the factory was designed and scaled for weekly production. We mean that the software and the systems are designed to be operated by teams so that we can support a weekly cadence of launches. And so it informs a lot of the details in the design of the system. This unlocks more launch availability, more scheduling flexibility, and a shorter time from book to orbit for our customers. And these are the things that we hear from customers are the most critical things to them. So how do we do this? Well, first of all, software. We automate as much as we can in the factory so that we can make more rockets more quickly with less people. But we also are driving the mission control and the on-site launch operations experience down from around 21 people to 8 people. And so again, a design point means that the mission control, which you can kind of see behind the rocket here, that's a pod. And the old one's right there. So there's iteration actually even in the concept of mission control. The number of seats, the number of screens, the ConOps is being evolved to use a fewer number of people, which translates into lower cost. And in this new model, the idea is a pilot and a co-pilot. If hundreds of passengers can get on a jet and fly across the ocean with a pilot and a co-pilot, why can't a couple of people fly a rocket that doesn't have any people on it with a satellite that's, largely most of them have to work for the customers to be happy? There's no reason. So as we think about innovating, we think about driving efficiencies in every area of the operation, including the recycle time at the pad. So the new launcher is designed to have a 1-day recycle time, which means we could ship a rocket, launch it, and then the following day do another launch from the same launcher. This means that we're going to have lower cost in operations, lower cost in anything that has to happen that's expendable at the pad so that we can continue to launch from a particular spaceport more and more frequently. Truly, potentially, if we accomplish this objective, operating a daily space delivery service from a single spaceport. The problem is that'll never happen because of weather, because of regulatory issues, constraints at the ranges, licenses, and so that's why we need more spaceports. And so you've seen the announcement last week. We're working with Saxavord in Scotland, and we have an entire team here looking across the entire world, looking at regions and areas where we can operate spaceports, because if you can truly take a mobile launch system and deploy it in anywhere that is happy to have us do a launch, then we truly allow the company to unlock the potential of launching from anywhere on Earth to anywhere in space. But the key is the system has to be mobile. You have to reduce the number of skilled on-site personnel that have to fly in, so that the fewer the people that are out there, the safer it is for the team. And basically, we're driving efficiencies and economies of scale, not just in production, but in operations as well. The second key design point is capacity. While many of our customers have very small satellites, an increasing number of large mega constellations have larger satellites that they're beginning to launch and deploy. So as we look out over the next 10 years or so, the average weight of a satellite, the mass of a satellite, is about 180 kilograms. Some are larger, some are smaller. But as Adam said, our objective is to address the majority of the market for mega constellation customers. And so with Launch System 2.0, our design point is 300 kilograms of payload to LEO. And you might ask how we do that. Well, first of all, it's a slightly larger rocket with more powerful engines. So we're actually moving to a larger fairing that has more volume for our customers to support the ESPA Grande standard, so that we can take a lot of common satellites that are being designed for other rockets and launch them on our rocket without having to design for our fairing. We're moving from 5 engines to 2. This reduces the cost, it reduces the number of engines we have to manufacture, and these new engines, you'll see here on the tour today, I think I have a video too, one running. It's a really cool engine, has fewer parts, doesn't have big batteries, uses turbo pumps, so it's a lot more efficient. And actually, I do have a video. So we're going to play a video of the engine that you're about to see on the tour running through its qualification acceptance test. This engine produces 35,000 pounds of thrust, so 2 of them will produce a total of 70,000 pounds of thrust. This replaces the current engines that produce about 7,000 pounds of thrust, so 5 engines that collectively produce 35,000 pounds of thrust are being replaced by 2 engines that collectively produce twice as much thrust. So 2/5 as many engines with twice the thrust. We have several of these engines. We're setting up a production line of these engines, which you'll see, so that we can reduce the number of total engines we have to produce as we continue to increase the production rate of rockets. It goes for a while, which is what you want them to do. While we continue to focus on capacity, we're continuing to drive costs down. And what this means is our base launch price will be only $3.95 million, which is a lot less than many of our competitors. And as Adam showed you, while the dollars per kilogram might be more, the dollars per launch remains low. And by continuing to offer what we hope to be the lowest price per launch, we'll continue to attract customers, especially as capital is more expensive for our customers, especially as we go into times of economic uncertainty. We believe that our customers are going to choose the lowest price per launch. And so it remains our focus to own that right side of the curve by continuing to drive costs down. And so as we look ahead, we're never done. The teams that work at Astra to make better engines, better stages, better rockets, better software will have a 3.0 right behind it. And with 3.0, we'll continue to focus on what our customers tell us they need. And every indication is that the capacity will need to continue to ever so slightly increase. How much? We don't know. But our customers are telling us now. And as constellations like the Kuiper constellation fine-tune and finalize the mass of their satellites, we can make adjustments because 1.0 is flying, 2.0 will be tested and flying for a while, and then there'll be a 3.0 and a 4.0 and a 5.0. And so this idea around continuous innovation, continuous development, and continuously listening to our customers and incorporating their needs into our products is what drives Astra. This might be the first product-led, customer-obsessed aerospace company. We can't hire product managers from this industry, right? Because products have generational life cycles. Typically, when you're an aerospace company, the product management is done by NASA. They tell you what they need, and then it's a cost-plus contract. There's not this continuous cycle of listening, iterating, incorporating that feedback loop into your products. And you won't see it here on your tour, but it's deeply embedded in the values and the culture of every single team member at Astra. And it's really special. So now I'm going to turn to space products briefly. In order to build space services, you've got to have the best space products. Your satellites have to have fantastic propulsion systems. They have to have power. They have to have radio systems and payload performance that's market leading. And the challenge is no suppliers exist to supply a mega constellation because there's really only one mega constellation right now operating, and it's SpaceX. And so we have to take every single one of these core space technologies and figure out as a company, how do we scale this? How do we take what we've done with rockets and launchers and apply it to these other key critical space technologies? Take this factory that we've built. Take the vertical integration capability, the ability to do the test facilities that you're going to see on your tours today, and apply them to every critical core space technology. Our first space technology we acquired last summer with the acquisition of Apollo Fusion. I'm proud of this team. I'm proud of the work they've done because we've already sold 82 of these engines. And if you listen to my earnings call last week, we sold 61. And so this product is working in space. It's being adopted by customers. And the more of these we make, just like the rockets, the more the cost comes down, which means the more we're going to have market-leading space services potential. And again, we're just getting started on identifying the strategies that we're going to use to introduce new space products that are going to power the space services. So on to space services. The team here, as we continue to make progress on our launch system, is making very strategic investments in building the first prototypes of the Astra spacecraft for our constellation. And all I'm going to do is tease you with it here today. This is going to be something that we will apply the same values, the same culture, and the same approach to. But we're not going to build it by integrating a bunch of parts. Ultimately, what we have to do is we have to bring the best space products to bear so that we have the best capabilities on orbit. And the great thing about that is that creates revenue potential for Astra. Potential in taking the best technology, productizing it, and selling it to our competitors. Just like a popular electric car company said, if we want to electrify the auto industry, we need batteries, and sold batteries to many other automakers. We see an opportunity in building revenue streams for Astra around taking our ability to get to space fast, develop our own space products, space qualify them faster, and create opportunities for Astra and our customers to have the best space technologies in their constellations. And the fact that we've sold 82 of these spacecraft engines is an early indicator of the value of this opportunity. So with that, we're going to show you the exciting stuff. You've had to listen to me and Kelyn, but I'm going to introduce Benjamin Lyon. After 23 years at Apple, where Benjamin led a lot of the core technology development in the iPhone, robotics programs, after many, many months of coming in, visiting, and hearing what we were doing and hearing about what we were trying to do for Earth, he left Apple to join Astra. He leads engineering, launch operations, he leads manufacturing, and today I hope you get the opportunity to tour with him because he's going to take you to all the places. He's going to show you a lot more detail into how we're pulling Launch System 2.0 together and some of the other core space technologies. So with that, Benjamin Lyon.
All right.
Yes, sir.
Nicely done. Thank you, Chris, and thank you everyone joining us here today as well as online. It's super exciting to welcome you here to Astra. You know, to me, small, cross-functional, and diverse teams that are largely independent are like part of our secret sauce, and it's what enables us to move so quickly, and also will enable us to adapt as we learn more and more about the market as the market evolves. And so when you get these really small teams, it really makes the magic happen. And rather than kind of tell you about it, I'd like to just show you. If you think about the factory that you see today, this is what most of it looked like less than a year ago. And we have this amazing real estate team that took this and turned it into this. And then this. And now this. And for us, once you have an incredible space, then you can start to facilitize it with all of the capital equipment needed really for scale. And when we think about what equipment to bring in, we think about automation. And we think about particularly what automation makes sense for what we're doing here. On one hand, we want to do scale. On the other hand, we know that the market is evolving, and so we're very tasteful about where we bring in automation in order to drive up tack time, but also have the flexibility in order to adapt as we learn. And so in general, where we see activities that are highly repetitive, we bring automation, we bring robotics in order to speed those things up, and you'll be able to see some of that today. In addition, we've been deeply investing in people. Our team is an incredible team. It's incredibly diverse. They come from all over the industry and all walks of life. It's one of the most exciting things for me personally about working at Astra is that I get to work with people from all various different backgrounds. This is Felix here. He's one of our lead weld engineers. We have Susan and Tim here. Also, they do welding and they do assembly and test. We also have a great intern program at Astra. And one of the great things about interns is that they don't know what can't be done. And they ask the most incredible questions. And those questions often cause us to go, oh, you know what? That's not the way we did it in aerospace. It's also not the way we did it in tech. But guess what? That's a brilliant idea. And because we're nimble, we're able to like turn and make changes based off of those ideas. You know, here we've got Emily and Nick working with Kyle on the assembly of our fairing. The other thing that we've thought deeply about at Astra is all the challenges that we already see the world is seeing in the supply chain. And we think hard about vertical integration, but we also look deeply into where can we have great partnerships with the supply base. And so Will Drury actually joined us from the automotive industry and has built out this incredible supply chain team that is working deeply with the supply base in order to get ahead of a lot of these supply chain challenges. And it's what's enabled us to have multiple rockets in build that you see here today at the factory. And of course, that comes together to this launch system. And one thing that you may not note in this picture is actually that strong back, which you'll also see next to the stage over here, is not only the thing that supports the rocket before a launch, but it's also the packaging that we ship the rocket with. And so this mobile system has parts that actually have multiple purposes to them. And for example, we can drive it down the road in Alameda in order to take it to the airport, and we can put our mobile system on an airplane and fly it to the spaceport. Or we can put it on a boat and we can ship it out to a spaceport somewhere else. And it's not just the vehicle, which is kind of the thing that everybody sees, but it's also the rest of the launch mount and the support system that's needed in order to make a launch really happen. And so this is, for example, what we call the cube, which is the launch mount, which we can literally stick it on a truck, we can ship it in an ISO container, and send it off to the spaceport. So as we think about mobility, we think about adaptability, we think about scale, we're not building one at a time in an artisanal way. We're really looking at building parts in volume, and that allows us to drive costs down. It allows us to drive quality up and reliability up. And so that leads us to have multiple rockets out on the floor today, and we think that this ability to rapidly produce but also be flexible is the critical secret sauce to being responsive and providing responsive access to space. And of course, when it all comes together, it's really magical, but we're just getting started. And we've been getting to work on the next generation. And so thinking about the next generation, you know, Chris showed this picture of an aluminum can, and from the outside, it really looks like an aluminum can. But there's a lot of complexity actually on the inside, some of which we really can't show you. And that complexity drives cost. And when we think about that, we think about everything that goes on the inside as a feature. And some of the very best features are the features that don't exist at all. And so we've been thinking very hard about how do we simplify, how do we drive out complexity, because the simpler the system is, the more we can scale it, the lower cost it's going to be, and the more reliable it's going to be. And so this is like a hard problem. Rocket science is hard, but one of the things we can leverage is the fact that our system is sending payloads to space as opposed to people to space. And because we're sending payloads to space, we can think hard about a system that is reliable, but is not the 99.9999999% reliable, because we're not worrying about a human-rated system. And so that's one of the aspects we can use to optimize. So as we move forward in our roadmap, Chris talked about how we are moving from multiple smaller engines to just a couple larger engines. And we have a facility today that's actually just across the street where we test first stage engines, upper stage engines, and upper stages. And that's great. But this is another one of those things where we realized, oh, shoot, we've got to build a facility that can test these much bigger engines. And we've got to do that quickly. And so once again, one of these very, very small, cross-functional, independent teams got together, and over the course of just a few months, started with this, went to this, poured a bunch of concrete, mowed the lawn, dropped in tanks, put up a thrust structure, and now we have a facility that is commissioned for testing much larger engines. And to me, this, again, like, it's just mind-blowing how small cross-functional groups of folks can move so quickly and do such incredible work in a short period of time. We're also thinking about this from the perspective of mission control. When I first got to Astra, this was mission control. And even just over the course of the rocket launches that we've been doing over the last year, we've gotten mission control down to just a few people. And you've seen this in the live stream. And what's going to happen next is we're going to design a system that takes advantage of automation, has a great user experience, and allows us to drive down the size of mission control to just a few people. And that's really important because our goal is to operate at scale. And so we need a system that is, instead of being designed for people to operate largely manually, where then you add in elements of automation to kind of solve individual pain points, we're flipping it upside down and we're designing a system that eventually we intend to operate largely autonomously with humans in the loop, just to check the system along the way to make sure it's doing the right things. Also in space, Chris talked about the acquisition of Apollo Fusion. And this is an incredible photograph of one of the Astra space engine thrusters operating in a test chamber, in a vacuum chamber. And for me, this was on my bucket list of things that I wanted to see in my life, was a Hall effect thruster actually operating. But what was even cooler than that was to see it operating in space. And this has generated a kind of a perfect match that has allowed us to think about, okay, there's a great kind of product market match. Now we need to go and we need to mass produce Astra space engines at scale. And so that is a project that is already ongoing today. And you can see we are producing Astra space engines already at this point. And that will be something that we continue to build out over time. And not only do you build it, but you've got to test it and produce it. And so this concept of scale is fundamental to what makes innovation really matter. We iterate really, really quickly. We innovate really, really quickly. But we have to be able to do that in a way that is at scale and that is impactful. And we believe that if we do those things and we do those well and with competence, that will create access to space and will create great business opportunities. And so what I'd like to do is I'd like you to meet Martin Attiq, who's our Chief Business Officer, and he's going to talk with you a little bit more about that. Martin, come on down.
Thank you, Benjamin. And thank you all, and welcome to Astra. I'm Martin Attiq. I'm Astra's Chief Business Officer. Our mission is to improve life on Earth and space. The way we do that is by providing access to space. And we believe that the potential for space is tremendous. It's already large. Chris talked about the current space economy is about $337 billion. We believe that there's a tremendous amount of unlocked potential. And the key to unlocking that potential is access. So what I want to tell you today is share with you what I hear every day from our customers and industry partners about the pain they feel in getting space access and where we believe the future of space access will be. And I'm going to start with an example. Imagine that you're an entrepreneur or an executive at a large company, and you want to build connectivity for autonomous vehicles. Autonomous vehicles require level 5 driving. What level 5 driving means is that you need to be connected to a network or a high availability network that is reliable. To achieve that, you need connectivity that you can rely on. With a terrestrial network, that's extremely difficult. You can't rely on a terrestrial network to always be connected. However, with space, it's very possible to be connected with a high reliable network. But then you say, okay, I have to go build this network. So how do you do that? Well, you have to design a constellation. You have to design, build, test, space qualify satellites and the components, ensure that they're radiation hardened so that they can work in space. You have to acquire spectrum rights so you can connect from space to the Earth. You have to build an entire ground network. You have to build a service model for customers. You have to hire a launch company to go and launch them into space. And then you got to maintain it all forever. That's exhausting. And what it also means is a tremendous amount of capital, hundreds of millions, perhaps even billions of dollars to go build this constellation. It also means you have to spend a tremendous amount of time and money to build the technology, all the R&D that's required. And thirdly, it could take many, many years. And so this combination of capital, technology development, and time are resulting in hindering the ability for the space economy to really be unlocked. So now imagine that you're that same entrepreneur or that you're that executive who's trying to build connectivity for autonomous vehicles. And I told you that instead of spending hundreds of millions or billions of dollars, spending many, many years and doing all this technology development, that you can instead just plug into a platform that already exists in space. That is our vision for the future of space access. This is not new. These transformations have occurred in other industries. This happened with cloud compute. For those of you that are old enough to remember, a decade ago or 2 decades ago, if you wanted to build a company or a product that's based on compute, you would have to go to a data center, buy a bunch of servers, get insurance, hire DevOps people, have 24/7 coverage, spend tens of millions or hundreds of millions of dollars to go build it out, and then you have to go maintain it all and make sure that you're up to date on the new technology and all the new security. And that experience sucked, and it led to, it inhibited the ability for startups to grow and for enterprises to grow. And this is the same transformation that we believe will happen in space. And at a high level, this transformation is not only new to compute and to space, these transformations have occurred throughout history, where you simply take something that is really cumbersome and has a high capital expenditure, and you turn it into a recurring revenue over the long term. So this opportunity is massive. Morgan Stanley estimates that it's $1 trillion opportunity by 2040. And I want to walk you through how we're going to solve the pain points of our customers in each of the phases, before we unlock it with space services in phase 3. So with phase 1, we have launch services that we discussed today that are low cost and they can provide ready access to space. With phase 2, we're developing core technologies and space qualifying them and producing them at scale so we can support the space economy with those critical components. And phase 3 is where we deliver a plug and play, where we leverage the idea that we have this incredible launch system and space qualified hardware to go deliver that plug and play solution. And we believe Astra is uniquely positioned to deliver that. Why? Because of this factory that we've built, the launch system that we've demonstrated, and the space products that we're qualifying. And ultimately, that's where we see the future. And with that, I wanted to turn it back over to Kelyn Brannon to talk to us about the financials.
Again, welcome to Astra. As Chris noted, we are operating in a very dynamic and ever-changing environment, and we are just beginning. As we discussed earlier, the space economy is estimated to be $1 trillion or more by 2040. And this includes satellite services, ground equipment, satellite manufacturing, and of course, launch. That means the space industry today is at an inflection point, and we believe Astra is well positioned to take advantage of this opportunity. The current market environment continues to make capital more precious and scarce, not only for Astra, but for our customers. With this in mind, and from Astra's chair, we have efficiently deployed capital in the following areas. Expansion of our production facility, which drives scale by increasing our production capacity. The acquisition of automation equipment, which will reduce cost and time. Our test infrastructure, which ensures we deliver the highest quality product and service to our customers. And lastly, continuous development of our product and services, which allows us to address our customers' need. When you look around and when you go on the tour, you will see these investments are focused on making Astra the low-cost dedicated launch provider, which is important to our customers as they deploy their capital. As some of you know, I was an executive with Amazon early on. I recall when Amazon began, their sole focus was on books and unleashing the distribution of books at a very large scale. By investing in many phases of the growth, Amazon has become a dominant marketplace that serves the world. Having said that, the Amazon we know today is much broader than simply selling and delivering books. For example, the AWS platform has enabled tech companies to build new applications without investing upfront capital in buying servers or leasing data systems with operating networks. Like Amazon, the Astra Space platform will allow our customers to focus on their application instead of securing launches, building custom satellites, and operating their own constellations. This will allow our customers to accelerate concept to commercial deployment of their products and services. We are laser focused on working with our customers to understand their needs and developing solutions that support their growth. As we look at our maturity curve for our different products and services, we expect there will be continuous development in our roadmap. Having said that, as you can see from the curve, we are extremely early in the development cycle for space services. Our early investments and achievement and operational milestones have led us further along the growth curve for launch services as we drive forward Launch System 2.0. Our initial investment in space products, through our acquisition of Apollo Fusion in 2021, we acquired the Astra spacecraft engine. This product has already achieved commercial success in 2022. The Astra spacecraft engine is already providing positive non-GAAP gross margin, and we have experienced customer growth illustrated by our orders for 82 engines as of today. As we think about funding to commercialization of our products, we intend to explore financial arrangements that is customary to larger capital-intensive initiatives to support the anticipated growth of our business. As we look forward and towards our long-term model at a steady state, which we have defined as the commercialization of products and services, we expect non-GAAP gross margin to be between 50 and 60%. On a non-GAAP basis, as a percent of revenue, we expect sales and marketing expenses to represent approximately 6%, research and development around 18%, and general administration around 6%, and adjusted net income of approximately 25%. Please refer to our prior earnings press releases for an explanation of non-GAAP financial measures and their reconciliation to the comparable GAAP financial measures. And with that, let's begin a Q&A session with all of today's presenters.
All right, we are heading to Q&A. I'm Katie Dom. We'll be taking a few questions from online, and we will also be taking questions from the room. So we do ask that you enter your questions in Slido. If you'd like to ask it live, a member of our team will run a mic over to you. So find some of these wonderful people. Our first question comes from online, and the question is from Jason Nevada. Why go to Rocket 4.0 versus sticking with Rocket 3? Sending this to the stage. Management team, take it away.
There's always a new version because we're always learning. The market's constantly evolving. We're always making more of them, right? So if you take the feedback from the production team, the feedback from the operations teams, the feedback from the customers, there's a huge list of things that you want to do to make it better, to make it safer, to make it more efficient to produce. And it's almost a question of you have to almost limit what you do, because you want to ship the next version so you can learn more, so that you can serve customers, so that you can get that next feedback loop. And so it's really a question of how long is the appropriate feedback loop with a product of this level of system complexity. And I think what we've experienced so far is in the 5.5 years of our existence, we've done 3 major releases of the rocket, 2 major versions of the launch system, or the launcher. And so I think we feel that 18 months or so product cycle gives us that right balance between capturing enough enhancements to the various products and getting that customer feedback loop incorporated back into the products. We're not going to make Rocket 3 and 4 at the same time. It's kind of like iPhone 12, 13, 14.
Great. Awesome. Next question is from online. Anu B has asked, what are some specific examples in Astra's vision for a more diverse space economy? What new products or markets do you envision being created?
That's a great question. Like I mentioned earlier, the space economy is connecting every human on Earth with high-speed internet, whether that's monitoring the Earth's climate. And we believe that there's a lot of potential that has not been unlocked yet. And that is because in the same way that for other industries, once you provide access, once you say, okay, we've driven down the cost of these things and we've driven down the complexity, new applications get created. And what we're really excited about is we don't want to create every new application. We want to provide access to space so that all the great entrepreneurs and product people around the world can create new products from space. And that's what fundamentally we're focused on.
Wonderful. I'd like to remind everyone we will be taking questions from the room, so please raise your hand and we'll come to you with a mic if you would like to ask a question. We'll have one more from online, but don't be shy. How does Astra plan on competing with SpaceX and other existing satellite constellations, and why does this set Astra apart from the competition? This was from Flavio.
I think does FedEx compete with Maersk? You know, to some degree. I think if you look at our mission of focusing on improving life on Earth, and you look at SpaceX's mission of creating a multiplanetary species and settling the solar system, spreading the light of consciousness, they're different missions and they're different purposes, and they're going to drive, at the end of the day, different engineering optimizations in the products that we build. And our products will serve a lot of customers, theirs will not, and their products will serve a lot of customers that ours will not. And so I truly believe that in that curve that we shared, there will be winners at both ends of that curve. And we could not be more focused on a different set of objectives. You know, we're focused on the number of rockets you can make in the factory, not the number of times that one rocket can fly, as an example. And when you have a system of this complexity, it truly drives a lot of engineering decisions that deeply affect your products and, frankly, segment the market. So maybe I'll hand the market aspect of that and then maybe the rocket aspect of that just down here for a second, because I think this is a truly important point. You know, I think that the market does have room and, in fact, critically requires companies like SpaceX to be successful on that side of the market, and actually critically requires Astra to be successful to kind of seed all these new ideas and all these new applications and all these new startups that need that low-cost, frequent access to space that will create this revolution and this innovation and this catalyst for new applications to be built that will ultimately then need the larger rockets as well.
Yeah, what I hear from customers every day is, I want to get my satellite to the right place in space as efficiently, as affordably as possible. And today, you can choose a large rocket, but it may not go to where you want to be. I think Adam said it perfectly when he talked about space has an address. There's an inclination, there's an altitude, there's an LTAN. And going to an address that you don't want to go to is not very useful for providing services. And so at the end of the day, when customers think about their business models, they think about how can I drive my revenue and how can I deliver for my customers. And for them, they want to build global constellations or broad constellations, and us precisely delivering to those specific orbits allows them to drive revenue. And so when they look at the value of, if I can get a satellite to a specific address, and that will drive hundreds of thousands of dollars of revenue per month, the launch cost difference is kind of immaterial to that equation. And so what we're trying to do is we're trying to be the best in the world at driving down launch cost, so we can deliver satellites precisely where they should be. And we think there is a world where someone like SpaceX can exist by launching really, really big rockets and going to a generic place in space. And we think there's a lot of room for companies who want to drive down the cost per launch. But there isn't a lot of room, we don't believe, in between. And why would you want to pay more either on a per kilogram basis for a large launch or on a per launch basis for a small launch? You wouldn't. And fundamentally, the products we're building is focused on driving down the per launch cost. And to Adam's point, we're less focused on building really cool technology that's not useful in driving down the cost.
I think that pretty much covers it. I'll just make one other point, which is, if you're one of many, many customers on a container ship, your individual importance to that container ship company is significantly less. We love working with our customers and being very, very responsive to them. And so for us, this is kind of a perfect match to our DNA.
Thanks, Benjamin. And so now we'll take a question from in the room. We have a question from Tim Dodd in the front row right there. So Elliot will come up to you with the mic.
Hi, everybody. Thank you for taking questions. Could we just get some more details on the actual new rocket itself, on Rocket 4? It appears to have like 6 times the performance, but double the thrust. So are you still using pressure-fed upper stage, or are you going to pump-fed upper stages? Is it all Keralox? Can you give us just kind of all the rundown, the detail on the new vehicle?
I mean, I can share that it's pressure-fed upper stage, Keralox. We're moving to turbopump-fed first-stage engines from electric pump-fed engines. Larger diameter. It'll be slightly longer. It'll still be critically a mobile launch system, so the rocket will still be transportable in shipping containers. And that's kind of a key design point that we think is important because it really differentiates us from the large rockets. When you can really pack the entire thing up, put it in a plane, a truck, a train, a container ship, move it anywhere around the world discreetly, and move it to all these spaceports that we're working really hard to open up across the world. Hopefully that's enough.
We can follow up on that too more later. We'll take another question from online from Hashim A. Why did Astra decide to acquire Apollo Fusion rather than building similar technology in-house?
Maybe give that one to Adam.
I think the short answer is capital efficiency. To, from scratch, go do and develop something as complicated as a Hall thruster is a big undertaking. The Apollo Fusion team spent years really, really working on it, iterating it, improving it, figuring out how to make it mass manufacturable, et cetera. And it was a great product that we're excited to incorporate into our common platform. And so I think in general, as we look at space products, some it will make sense for us to develop internally, others it will make sense for us to partner with folks, others it will make sense for us to license or even acquire.
And I'll just add, one of the big pain points in space is you have to space qualify things, and it's really complicated technology. And we found a team that had worked on thousands of satellites that are currently working in space. So we found this phenomenal team, world-class team, and we tested out their technology, and they space qualified it, last year. So that endeavor of getting from initial concept all the way to space qualifying a really critical component, and propulsion, satellite propulsion is one of the most critical components, in space. To find a team like that had made that much technology advancement as efficiently as they did, we thought was phenomenal. And we could not have been more pleased by the market reaction. Customers are in love with this product. Chris mentioned that we just added 20 more spacecraft engines this past week, and the demand continues to be really strong because this stuff is really hard. And that's fundamentally what Astra is about, is improving access to space. And if we can mass produce a product like that to help people get access, that's what we're all about.
Wonderful. And we have time for a few more questions. I think gentleman in the blue had one question here. Elliot?
Good morning. I certainly appreciate the vision of trying to move things quickly, right, from a customer perspective. Getting access to space is important. And I'm excited that you guys are looking at foreign launches because certainly there's going to be opportunities to put constellations up that will require efficiency in that launch profile, and accessing that is going to be important. I'm wondering if the Astra team has considered acting as an integrator for things that involve either EAR or ITAR, and doing a single license application that would include the payloads that may be restricted for that foreign launch as well.
Yeah, when you look at these issues around ITAR and EAR, these are primarily U.S. export issues. And so by operating a system that can be totally containerized, deployed, launch, pack up, and go, while the U.S. maintains and U.S. citizens maintain control of the entire system, I think is a unique opportunity for Astra, just given the mobile nature of the system that we've developed. It also allows foreign countries to effectively offer sovereign space launch capabilities. So there's over 70 space agencies, and it might be, it's interesting to note that 7 of them have access to space. And so we see that as over 60 sovereign national space agencies that we could potentially partner with, certainly our allies, and certainly ones that have already kind of cleared some of these export issues through TSAs with the State Department. And so we're going to basically start with our closest allies and partners that have already gone through this clearance process. And then, as this allows us to continue to operate more freely, we'll hopefully have more partners that want to partner with Astra. I mean, this is about democratizing American space technology, and not, taking some of our best satellite technology and exporting it to countries for foreign launch. And one thing that geopolitically did evolve in the Ukraine is all the Soyuz launches stopped. So about a third of the global supply of launch was taken off the map in the last couple months. Constellations like OneWeb were left without a ride to space and scrambled to partner with companies that were in some cases competitors to fly their satellites. And so I think this is a really interesting and dynamic geopolitical environment where access to launch has never been more constrained.
Wonderful. We have one more question. We are running out of time and we want to get you on tours, to lunch. We will address your question, so make sure you just ask your host or the person who is on, or one of your tour guides, and we'll make sure that we're able to address those things. Last question is, can we have more insight on Astra's plans to build the AWS for space services? And then it's followed by one other question, which I think is great, which is, how is the Rocket 4 development progress going, and will it launch in 2022?
So we're making good progress, and we don't announce our launch dates well ahead of time, as we've discussed many, many times before, that there are many, many things that can affect when we launch and how we launch. But we've got a great team. As you walk around today, you'll be able to see for yourselves much of the progress that we are making along that path. One of the most critical pieces to a successful launch is the propulsion system, is the engine system, and you saw the video today. So lots of good work going on there, and then I'll leave the other half of the question to Chris.
Well, we're not ready to announce something specific on space services, but the thing we are doing is we're talking to customers today about being customers of our space service, because they see the value of that. And the engagement we have from customers today is more strategic than it's ever been, because we're talking about immediate concerns around just getting simple access to space, so that's launch. Future concerns around being ahead of the game in technology, so that's building core technologies and space products. And then thinking longer term, why am I even doing any of this stuff? Why am I building all these satellites and managing these constellations and putting up with all this capital and maintenance? Why don't I just plug into a service? Now, there will always be, we believe, customers that will want to launch their own satellites for for a variety of reasons. But we believe that portfolio mix of launch services, space products, and space services is an interesting mix to basically democratize access to space.
Wonderful. That's the time we have. We're excited to get you onto tours. Chris, do you want to close things out for us quickly?
I want to thank all of you for coming from New York, from LA, from all over the country here in person, and for the hundreds of people that are joining us on our live webcast. Thanks for tuning in. We're going to package all this stuff up and put as much content out there as we can. I know transcripts are being made. We're going to be making the presentations available publicly. And this is the first Spacetech Day. We're excited to make this an annual event given the incredible response. And we're going to be putting a lot more thought into how we can expand and provide an even greater opportunity for all of our shareholders, customers, partners, to kind of see what we're up to and just kind of allow you to keep checking in. If you were to be here a month ago, basically nothing here behind you was even there. Right? If you were to come here 6 months ago, the construction wasn't even done over here. If you were to come here a year ago, the sample rate of velocity for Astra is high. And if there are people on your tour that have been here before, just ask them how fast we're going. We truly were in a garage just over 5.5 years ago in San Francisco with just a few people. So what you're experiencing here is as much about culture and values and commitment to a mission and customers as it is about any hardware or anything else that you'll see. And that's why I know that there'll be a Rocket 4.0, because there was a 3 and a 2 and a 1.0 that all happened in the last 5 years. And so the teams could not be more, we've never had more people working more passionately for customers that are depending on us than we've had literally right this moment. And tomorrow, there'll be more people, and as we continue to build this team out, you're going to see more velocity, more commitment, and more products. So thank you so much for coming. Look forward to see you all on the tours. We have, I think, 5 or 6 tours that'll be starting right now.
Yes. We ask that you check that your lanyard out. You are grouped by color of lanyard. So if you are in a specific group, we suggest you start coming together. Your tour guides will find you. We do ask that all phones are placed into bags during the tours. If they are taken out, you will be escorted out of the building. We are very serious about this. Other than that, we have great things for you to see. We have lunch. Please ask if you have any questions, and we're so thrilled that you're here.
And thus concludes the first ever Astra Spacetech Day at their Bay Area rocket facility. Some interesting information about Rocket 4. It's a quite a bit larger rocket in diameter. Sounds like it'll be just slightly taller. If you haven't yet, follow us over on Twitter, TLPN_official. We were live tweeting updates as they were going through them, and we'll tweet out the presentation once we have that. If you haven't yet, join us over on our Discord as well. Links are all in the chat. It's free to join. We've been hanging out in live comms, as we do during any of these presentations, chatting about what's been happening. But as we wrap up, let us know in the chat what you think about today's presentation, about Astra and their future. But that's going to wrap it up for us here today. This is Zach from TLP Network Studios, signing off. We'll see you next time. Bye-bye.